Hello. Uh, Today I want to talk about uh, VECA and preparing some information about how we can use VECA for some pre-processing uh, steps in data mining. This is VECA software, and firstly, I'm choosing Explorer button. Okay. In this window, we can see the pre-process tab is activated and the rest of tabs are deactivated because we should first choose a file uh, to import in Veka. Okay, I'm choosing open file, and I'm trying to find Veka example. Here in the installation path of Veka, there is a data folder, and in this folder you can find some data sets, data sets. For example, I can choose one of them. For example, I'm choosing Iris here and clicking open. What is ARFF? Here, when I'm trying to open a data set, we can see that the primary file type that Veka supports is ARFF. But what is ARFF? Here in Notepad++, I opened some ARFF files. The ARFF file type consists of two different sections. In its header file, in its header, for example, in this example, cpu.arff, in the header, you can find some definition about the name of dataset and its attributes in these datasets. For example, here you can see keyword @son relation and CPU. CPU is the name of these datasets, and after that you can see keyword @sign attribute and names of those attributes in these datasets, and after that type of those attributes. Here, for example, in CPU, we can see that all attributes, 7 attributes, are here in this dataset, and you can see type of these attributes, all of them are numeric. But for example, in Iris ARFF, we can see that there are 5 different attributes. Four of them are real attributes, and the last one, attribute class attribute, we can see that this attribute is nominal. So different values related to this attribute is presented here in this way between these accolades, the opening accolade and uh, closing bracket here. And after this section, after defining different attributes and their types, we have the second section of ARF file type. This section is started with @sign data, and after that, the values of those records in these data sets are presented. Each value is separated using a comma from other values in a record. Okay, you can use this um, uh, percent character to write some comments about your datasets, for example, but it's not necessary. It's an optional case here. For example, I have a dataset name. Its name was adult dot data, and it's just consists of values. And I have another file. It's adult dot names. In this file here, um, I have some definitions about the attributes and their values. For example, age is a numeric uh, attribute, word class is a nominal attribute, and rest of them. Uh, Based on the structure of ARF file, I made a file adult.arff. Here you can see that I firstly I'm writing the header of this file, adds a relation and adult name of these datasets, and using adds an attribute keyword. I'm adding name and values of uh, different attribute in this class, and also I add a new attribute. Its name is class, and its values are less than 50k or higher than 50k. Here, class attribute, most of the times the class attributes is placed at the end of each record. Okay, so this is the ARFF structure, ARFF file type structure. I can change uh, other files into ARFF datasets, and I can choose them. Then I can choose them to enter into Veka. Also, in Veka you can upload CSV data files too. But here, I want to work with ARFF file types. Okay. After opening a file, dataset file in Veka, you can see some parts in the preprocess tab. Here in current relation, you can see name of these datasets, number of attributes in this data set, number of instances in these datasets, 150 different records, and name of attributes. Here, when I'm choosing class attribute, if I'm turning back here, I can see that the class attribute in iris.arff datasets has three different values: iris statusa, iris versicolor, and iris virginica. And here I can see something similar here. Class is a numerical attribute and it has three different attributes. Each of them, each of these attribute values has different 50 separated records. We have 150 different records in these data sets, and in 50 of them the class label is iris sedusa. In 50 of them the class label is iris versicolor, and in the last 50 the class label is iris virginica. You can see them here. Three different classes. Each of them has 50 member. Okay, and there is no missing value here in the selected here in this uh, window in the right corner, in the right side, you can see that the class label, the class attribute has no missing data. Its type is nominal. Its name is class, and you can find different information about this attribute. But for example, if I choose a numerical attribute, for example, spal length, spal width, or something like that, you can see something similar. Name of this attribute type is numeric, and spal width has no missing value, but this attribute is numeric, so we can prepare some statistical information about this attribute. We could prepare them. Spal width, the minimum value for spal width in this dataset is 2. The maximum value is 4.4. The mean value of this attribute is 3.054, and its standard deviation is 0.434. So simply, if I choose an attribute, if its type is numeric, Vecad will prepare some basic statistic information for me. And also here in the bottom, right button, you can see the distribution of that attribute related to the class label. We have three classes here, and if I choose one of these attributes, I can see that how this attribute is distributed. The value of in this attribute is distributed according to the class labels. For each attribute, we can see a different distribution here. After selecting and uploading a file, you can see that the rest of tabs are activated too. But currently we don't want to work with them. Just here right now, I want to work with visualize tab. I can use this one, this button here in preprocess. If I choose visualize all, I can see how the distribution of this file is related. I can see the distribution of values for different attributes here. But if I choose visualize tab, I can see more relations and more data about relations between different attributes. For example, if I choose and try, if I try to find relation between, for example, relation between petal length and spal length, here I can see that these two attributes, spal length and petal length, have positive correlation. Look at their distribution. The distribution shows that they have positive relation. And also, we have three different classes, and you can see distribution of different items according to spal length and petal length. Members of each class are distributed in this space, in this diagram. You can see that the iris setosa is completely separated from the rest, and in some cases here in the middle of this diagram, you can see in some cases some records belongs to iris versicolor um, are mixed with iris virginica. I can double click on each of these instances and I can find their values. For example, if I choose this one and double click on that, this is instance 149 and different values of this instance are presented in this window. Okay, I can change this and finding different relation um, and correlations between different attributes in this datasets. If I change jitter, uh, jitter can help me uh, make it more clear. Look at this. It jitter will add some random noise into data and it seems it can make it more clear to show the distribution of my data in these datasets. Okay, also I can see distribution of data for different attributes in this data sets. If I look at this, petal length and spot length has a positive correlation, but for example, here petal length and petal width has positive correlation, but in this case, for example, we cannot see a positive correlation. The correlation between spall width and petal length is very low. It's near to zero. This correlation between them is near to zero. Uh, I cannot see a positive or negative relation between values of these two attributes here. Or this one, spall width and petal spall length. They have no correlation together.